Have you ever thought about an object that is so bright that it's 25 trillion times brighter than our sun? Well, I have, and it exists. Quasars. But what are quasars? Quasars, or quasi-stellar radio sources, are the bright centers of galaxies. See, each galaxy has a black hole at the center. For example, in the center of our galaxy, the Milky Way, we have Sagittarius A star. Do note that these sorts of black holes are supermassive. The general term we use for quasars and supermassive black holes in the center of galaxies is AGN, or active galactic nuclei. But to understand why quasars are so bright, we need to figure out what happens to these black holes. You know how stars and nebulas are made out of gases? Well, when something big happens in space that changes the gravitational fields, like merging galaxies for example, it makes a huge amount of these gases move toward a black hole, essentially feeding it. When a black hole gets so much gas to fuel it, it cannot eat it all at once, and so the gravity of the black hole makes the gas revolve around it. This forms an accretion disk. A black hole spins fast, very fast, and as a result, the gases around it also spin as the black hole's gravity pulls everything around it. This results in a lot of friction between these gases, and that heats up very quickly and turns bright, just like how a star would form, but it's around a black hole. This light being emitted from the heat being made by the friction of these gases is why quasars are so bright. However, if you look at quasars, you would think, what about those two jets coming from the quasars? This is one of the edges of astrophysics that scientists are still figuring out. All we know right now is that some of the gases or matter, when going from the accretion disk to the black hole, gets routed to the bottom and the top of the black hole, producing these jets. However, if the electrons from these gases are accelerated perpendicular to their speed and direction, these electrons can be launched as a wide variety of wavelengths in the electromagnetic spectrum. This is called Synchrotron Emission. Now that's some high-level astrophysics. It is through this reason that quasars are quasi-stellar radio sources, as that's how scientists first found them, by detecting their waves. These jets and accretion disks are so bright and far-reaching that they're brighter than their own galaxies that they reside in. Now, why are these quasars so important? Well, actually, there are three important use cases for quasars. They help find new distant galaxies. As I just mentioned, that these quasars are brighter than the galaxies they reside in, and that they are active galactic nuclei. This helps us know that a galaxy is there whenever we see a quasar, and helps us further map and understand the universe. Quasars also help find the history of the universe. Quasars are millions of light years away from the Earth. Light years are the distance covered if something travels for a year at the speed of light. So if something is millions of light years away, then the light will take millions of years to reach our visibility, so quasars can actually be a lens into the past. Okay, but what impact do quasars have? While we can think of quasars as really huge black holes, we also need to think about how much matter these supermassive black holes consume. And as we've talked about how black holes are very hot due to the friction caused in the gases around it, this heat can radiate around the area on the black hole. This excess heat can heat up other gases and make the gas too excited to settle and form into a star, making space have less light as time goes on. But quasars could also just consume so much matter and gas that there eventually wouldn't be enough gas to form stars. It's a pretty sad outcome, I know. However, this happens in the span of millions of years, even billions. And that's pretty much what quasars are, just supermassive hungry black holes that send out waves and energy billions of light years away. Thank you for watching.